Hi, and hello to the video for SAP HANA and SUSE HA availability on public cloud. This video will be done and recorded by Andreas Hennig. I'm responsible for the pre-sales for Western Europe within Intelligence. I am supported by Stephen Mock, who is the EMEA pre-sales responsible for SUSE. And we would like to show you in that video how to build a stable SAP landscape in the cloud. For that, we have a quite structured agenda. We would like to start with an overview of what is in for or what you need to consider for a SAP high availability scenario. Then I will hand over to Stephen for the public cloud solution and managing SUSE high availability cluster. And finally, we will be again with me for the sub-part on public cloud. So I would like to step in directly. Of course, we always have to consider not only the SAP main application, but besides the main application, there are a lot of additional things you need to consider as well. Besides the well-known central instance with a database, you will have maybe application server, you have something like a Fiori gateway, you have cloud connectors maybe, there might be a document service and other things you need to consider during this build of an SAP system. And for these, you always need to consider that not only your central instance is high available, but also the other applications which are relevant for the SAP system and which only gives as a complete environment a clear view to your customers and your own people will be available. Therefore, you should consider several things. Of course, you always can do everything with just the OS operating system, and here we have with SUSE a quite competitive cluster software which gives you a lot of functionality within. But I would like to raise some additional topics here, as we have also within SAP their own functionalities and possibilities to have here a high availability. As an example, I mentioned here the options on the right for each individual application, but I would like to highlight in the next two slides two special things. The first one I would like to highlight is the NQ server. Here, each work process for ABAP has its own connection into the NQ server, and the Java for Java, each server process has its own connection into the NQ server. After the NQ server is started, it will open the port to be able to add an additional replication server, which is in the normal state just as a standby running at the same time, updating the replication table. When the NQ server might fail, the main one, it will then start with the help of its own HA software. It will start the NQ server on the host B and will copy the replication table into the new created NQ log table. The HA software in that case will take care that all requests will then be handled by the host B instead of host A. In case the replication server will fail, you just can build a fresh one and connect the one to the NQ server, and it will update the replication table on its own. The other thing I would like to mention is the example around the SAP Cloud Connector. Here we can also leverage the own functionality with delivered with SAP. And here we have a kind of a master-slave configuration where we have one active instance running for the sub-cloud connector, and in the case of an outage of the primary one, the slave, the second one, will take over. To make that an easy and a small configuration, you can of course deploy that also with Docker and similar configuration. To step now a little bit deeper into the techniques around SUSE cluster, I would like to hand over back to Stephen.
Okay, thanks, Andreas. So before I dive too much into the technical side of the cluster components, I just wanted to talk a little bit about SUSE public cloud solutions and what we have out there. So SUSE has been working with the public cloud vendors for probably as long as public clouds have been around. So during our years as partners with AWS and Azure, we've helped thousands of customers move enterprise workloads into the cloud. Now, if you go back 10 years in time, we were the first commercial Linux, which was available on AWS. 5 years later, we had things like SLES for SAP, available on AWS and on Azure. And just a couple of years later, that's in GCP as well. And a short while after that, we realized that innovation doesn't stop at just making Linux available in the public cloud. So we've worked with Azure to develop an optimized kernel to have a streamlined footprint for Linux inside Azure for some of those more basic workloads. And eventually we have SUSE's cloud application platform, which is SUSE's cloud native development experience, is also available across the various hyperscalers. Now, there's no denying that public cloud usage has accelerated over time, and quite simply, it's probably everywhere and nearly everybody's using it. And cost cutting is probably the number one reason at the top of the list why customers are moving to the cloud, with things like new features and capabilities coming a very close second. So take SAP as a good example. It is a critical workload to any business, and it's normally surrounded by a very robust set of SLAs. And in conversations I've had with customers over the years, if you go back a couple of years, those conversations were things like, should we move SAP into the public cloud? And if you have those same conversations today, the question is about when are they moving SAP to the cloud? Now, with things like SAP Embrace and SUSE best practices providing reference architectures, the trailblazing element of this type of project is long in the past. So SUSE has had to keep pace with the demand of our customers wanting to make this leap into the cloud, whether they're running SAP or other workloads. So we've had a public cloud engineering team, which has probably grown at the same pace as cloud over the last few years to help our customers. So what do we offer in the cloud today? Well, as you'd expect, SLES and SLES for SAP form the majority of what we deliver in the cloud. But we also have things like SUSE Manager, CAS platform, and our cloud application platform available across the hyperscalers as well to allow you to manage some of those workloads that we're putting up into the cloud. And for some of the CSPs, where they have specific instance types or specific use cases, we work with those CSPs as well to make those particular instances available. So inside of AWS, they have ARM-based instances, and we've had to develop images to be able to support our customers who want to run SUSE Linux on those ARM-based instances in AWS. And then in things like Azure, we have an offering around HPC. So again, we have specific images and instances which we offer to get the most out of the Azure platform if you're looking to run any HPC workloads. So one of the things I wanted to talk about was what the public cloud engineering team do. And part of their role is managing what we call our image lifecycle. So when you deploy an instance into the public cloud, the VM you build comes from one of our published SUSE instances, or at least it can. And to ensure those images are kept as up to date as possible with all the latest security fixes in, we refresh those instances in the Azure and AWS marketplaces on a 3-month rolling upgrade. So every 90 days or so, we'll refresh that image to make sure you get all the latest, greatest fixes and updates automatically as soon as you start that virtual machine. Now, if you want a little more control over what images you deploy or what you base your VM around, SUSE have a tool called PINT, or the Public Cloud Information Tracker, which allows you to query the various images that we have available across the hyperscalers. It's very easily deployed. Just one package that you need to install, as is mentioned at the bottom of the slide there. One thing that is worth talking about is we also have something called a BYOS image, or a bring your own subscription image. They're not refreshed on a 90-day basis, but we will refresh them if there's any significant security issues which need to be bundled into that image. So of course we have our two flavors. We've mentioned BYOS already. The other is pay-as-you-go, which is our standard offering. Let's drill a little bit deeper into those terms and what that means. So bring your own subscription basically means that there are two vendors involved in running Linux on the cloud. You have the CSP, which you use for your infrastructure, and you'll have an agreement with the CSP around paying for the infrastructure there. With bring your own subscription, it's exactly what it says on the tin. You're bringing a subscription into the cloud, which you've bought from either a SUSE partner or from SUSE directly. And when you start that instance, it actually has no fixes and updates available to it automatically. It's almost like an on-premises workload. You have to register that instance at least with the SUSE Customer Center, and that will add the repositories you need to get those updates. But once it's up and working, the next consideration is around support. In the same way there's two vendors to provide the purchase of the infrastructure and the operating system, there are two in the support routes as well. So you have the CSP who you go to for support around the infrastructure, but you also have direct access to SUSE for the OS as well. And that's great if you want that direct relationship with SUSE as part of a critical project. Now, if you need to manage a solution on these workloads for bring your own subscription, and you need a solution to provide repositories yourself, that needs to be set up by yourself, and the cost for doing that is down to yourselves as well. But again, BYOS is great if you already have subscriptions on premises and you want to take those into the cloud. However, it can add a little complexity around the support and procurement. On the other hand, we have our standard offering, which is pay-as-you-go, or we call it on-demand as well. And with that, things are a little bit simpler. Okay, there is one vendor involved, so one vendor that you go to for not only the infrastructure component, but when you start that image, it has a subscription built in which you're paying the CSP for. And again, in the same reason, there's only one vendor involved in the procurement side. There's only one for support as well. So your support route is via the CSP for both the infrastructure and for all the Linux queries as well. There's no real disadvantage of that. We have a very joined up process at the back end to push calls from the various CSPs into the SUSE Customer Center or the SUSE Support Center. So you should get a good experience whichever route you take. Now, one interesting thing is the actual machines themselves, the pay-as-you-go machines, will register automatically with our SUSE update infrastructure, which we make available inside the public cloud. So let's talk a little bit more about that. So in each of the major cloud providers, SUSE provide what we call an update infrastructure. And this provides an in-region set of repositories which the pay-as-you-go virtual machines can connect to for their updates. Now, the beauty of that is that it's very low latency. Right? This means that patching from our in-cloud infrastructure is up to 4 times faster than patching from something like the SUSE Customer Center, where you're potentially pulling patches around the globe. And the fact that it's in region, in the same location where you're running your SLES for SAP or SLES workloads, means that there are no network charges for moving data around inside the CSP's network environment as well. So for every region in which you can launch SUSE or SLES for SAP, we actually host an update infrastructure. And in order to deliver that service, it's actually quite an investment. We're managing over 300 servers across the hyperscalers, which are managed, monitored, maintained by SUSE. Each one's constantly checked for health, mirror status, and so on to ensure a good experience and to make sure those repositories are available to you when you fire up those pay-as-you-go instances. So at this point, I want to jump ahead now. All right, this is jumping ahead to a place where you already have your cluster built. Right now, there are a few SUSECON Digital sessions which you can watch and other supporting webcasts which show you how to build SAP clusters in the public cloud. And it's important to note that when you build them, each cloud vendor will have its own specific way of setting up different components like IP addresses and fencing and so on. But once up and running, the actual management of the cluster itself is relatively consistent across the various providers. So imagine at this point you have everything set up and you just want to understand the behavior of your cluster and how it might behave in the event of a failure. So which tools would you actually use? So one of the go-to tools that I use is something called CRMMON, and this is a command line tool which provides a summary of the cluster's current state. It gives you a view of which nodes are online, which resources have started, and which nodes the various resources are running on. Now, it comes with a number of options. The main ones that I use are -N, which allows you to display the various resources running in the cluster by node. So it's very easy to show which node the various resources are running on. And sometimes I use -1, which runs the CRMMON tool once and then exits out. So if you want to use it as part of a script and maybe pass the output for some kind of health check, you can absolutely do that with that command as well. But one thing to remember is it does need root access, or at least a working sudo setup to work properly. So you will need to make sure you have the appropriate rights to run this, otherwise you won't actually see anything. So here's an example output of CRMMON, and this is roughly what you'll see. And as you can see, we've used the -N option to group the various resources by the nodes that they're running on. And I just wanted to highlight a couple of resource agents which are running in here. And these are ones that you'll see on HANA clusters, no matter where they're running, on which hyperscaler they're running. So we have the SAP HANA database resource agent. So that's the actual database itself. And you can see we have one running on our primary node that's actually running the master copy of the database. That's where the clients are going to connect into. And we have another an instance running on our secondary node. And that is, our secondary node is basically our system replication target. Now, this cluster is running in AWS, so you'll be able to see IP address and fencing resources specific to AWS. Again, when we talk about Azure later, you will see the same sorts of things, but they will potentially look different. But what's key here is that we don't actually want the cluster to fail over if things aren't in sync. So we have something called the SAP HANA topology agent, which is there running on both nodes, and it's up to that agent to go out and take a look at the SAP environment and see exactly the state of the nodes and the state of system replication and report that back into the cluster. So how can you check that yourself? So one of the ways is to use the SAP HANA DR Show attribute tool. So with this, it's important to note that the information that it's displaying is actually fetched from something called the cluster information base. That's an in-memory database of sorts which the cluster keeps, and these are simply attributes inside the cluster which are being read here. But it's actually these that are referenced during a takeover. So as you can see from the sample output, you can see the hosts that we have, the role they play. The key things from this output are the letters SOK for the sync state. And again, if the cluster doesn't see SOK, we're not going to fail over. And the reason is pretty simple. All right, you do not want to fail over a cluster where the data is days or weeks out of date, because that will cause a huge amount of confusion for your business. So we'll never fail over as part of this HA unless that says SOK. Again, for this tool, you do need a working sudo environment or run the command as root. Otherwise, you don't have access to the cluster tooling that you need to run this. Now, if you don't have access or to the root user, and maybe you don't have sudo set up, then you can use some of the SAP specific tooling. So most admins will be familiar with the HDB admin tooling, which can take a look at system replication state. So I won't go into too much detail there. But one I do like is the various scripts which are offered to take a look at system replication as well. And as you can see, this particular one prints a human readable table, and you can see the replication status of the SAP processes should say active. Now, if they don't say active here, then either they need time to catch up if a large amount of data has been written to the primary, and we're perhaps waiting for the data to be fully in sync, or perhaps there's a problem. Either way, it needs to stay active or the cluster won't fail over. So as well as tooling, we need to think about the management of the systems as well. Now, In the same way that our chameleon has evolved over time, your SAP landscape is going to change too. And this will involve updates of not only the SAP software, but what I'm going to talk about is about patching the underlying OS and cluster software too. Now, consistency is key in an SAP environment. Okay, you want predictable behavior of the cluster, and it's important to keep all the software versions the same on the various nodes inside that cluster. Now, part of achieving that is to have a good software management process set up, and in that process there will be some kind of solution that provides repositories to the various Linux servers. Now, at an absolute bare minimum, you can use the public cloud infrastructure for the pay-as-you-go instances, or perhaps the SUSE Customer Center for those bring your own subscription instances. But more likely with something like SAP, you're going to go down the road of using something like SUSE Manager or a dedicated RMT server to the cluster. And this will bring some kind of structure and control to the patching process. Now, in terms of migrations, again, I'm just talking about the OS and the cluster software here, but sometimes the changes involve more than just applying patches. Sometimes you need to uplift the whole operating system either to a new service pack or perhaps even to a new OS major release. Now, depending on which upgrade path is supported will depend on which product you're going from and what your target product is. So, for example, if you need to jump from SLES 12 to SLES 15, which is perfectly possible inside the public cloud, it will be what we call an offline migration. And that means that we'll be needing to reboot most of the machines. We don't want to run a mixed cluster with some on SLES 15 and some on SLES 12, which means that all services will be down, which means that SAP, of course, will be down as well. Rolling migrations are supported within the same major release. So if you are going from something like SLES 12 SP4 to SP5, or SLES 15 GA through SP1 or SP2, then it's perfectly possible to do a rolling update, in which case you would patch your secondary server in the cluster. Once that patch is complete and you've updated the node, rebooted, you can move all your resources across to that node. And providing that works and looks like it's running well, then you patch the original primary, and then if you want to, you can move those resources back. Now, the benefits to doing something like that are the fact that you only get a small outage of the system, just the time it takes to do that initial failover between the primary and the secondary node which you've just updated. But it also provides a rollback plan where you can roll back to SLES 12 very easily just by moving the resources back if for some reason nothing's working when you make that jump to SLES 15. Now, the beauty is in SLES for SAP we actually have a YAST module which takes you through the whole upgrade process of a cluster and a whole rolling migration to ensure there's absolutely no loss of data. So keep an eye out for that inside the documentation. And then the last thing on here is you can do online updates where you don't necessarily worry about taking the cluster down. So you can do package updates, but only when the software that you're updating doesn't apply to the cluster itself. And then the last thing for me, and this is very easy for me to say, is whenever you patch, whenever you apply a new service pack, or even jump to a new major release, please check the documents, okay? Check the release notes, and of course there is usually a test or a pre-prod environment with SAP, so please take the time to use that to test the cluster software as well, all right? Because the more you test, the more you understand the behavior, and hopefully the more success you'll have with doing these upgrades. So I think that's enough for me. What I'll do is I'll hand back over to Andreas to take us through some of the SAP tooling on Azure.
Okay, thanks for that, Stephen. I can definitely approve that backup is a very urgent topic, and we always need to make that upfront. And I would like to highlight some additional topics you should have an eye on when going into the public cloud. Of course, always, you just mentioned it, backup concept is key. And that does not necessarily only mean you have done a backup before you push over to the public cloud. No, you also need to consider how to back up within the cloud. Because on-premise you are quite used to use a lot of native tools which are able to back up also do a point-in-time recovery of the database server. This is not by default available in the public cloud. An additional important topic is how do you access your environment? Do you need an access from the internet? Would you like to have only access via VPN, MPLS, whatever? How is your admin accessing your network in case your VPN is down? How are externals working on your systems? And therefore, there are a lot of things to consider. Also, within the environment in the public cloud, you also need to consider how to segregate your network. You would never build everything within one environment or in one network environment, offering internet access to that environment. That definitely makes no sense. So you also should consider a jump zone, a DMZ zone, an SAP zone, a database zone, whatever is required. Also, migration strategies are interesting. There are always the possibilities for SAP doing homogeneous, heterogeneous system copies. But for some applications, native tools of the public cloud providers might help as well. And you should also take that into consideration. Monitoring is key after you have brought your environment up to life. You need to consider all the relevant reportings within SAP, like early watch reports, like all the updates and all that stuff you would need to run your an healthy environment. In public cloud as well, in your private cloud, antivirus protection is key. We see more and more virus patterns coming in each year, so it's really important to have all these things considered. And of course, you need to have qualified reporting to be able to see after you run your systems for a certain time if everything is running smooth, if everything is working according to your SLAs, and so on. And beside that, you need to always consider to have all relevant software vendor supports. Okay, when you then go into the public cloud, and for the next slides, I will concentrate a little bit more to one public cloud provider. Here, I would like to focus on Azure, as that makes it easier for me to explain more in detail the options you do have. Of course, one of the key things, always use the single VM availability in the public cloud, especially on Azure. That is quite important because I will mention the other SLAs afterwards, but unfortunately, not all are quite easy to achieve for an SAP system. If you just consider some basic things like you're using premium disk, you're using the dedicated and certified VMs for SAP, you got an SLA of 99.9% for a single instance. That is quite unique on Azure, as here we are granting the availability already with one machine. And that is one of the topics we really need to consider, because using an availability set or an availability zone, which gives us higher availability, is not possible for all applications. You might remember there was always a saying, SAP and the central instance has a Highlander principle. And the reason for that is that you can only deploy one central instance. So you either can give the central instance a higher availability by using the SUSE cluster, but unfortunately you can't use the availability sets and availability zones, because one of the prerequisites for that is that you have, let's say, a quite dump infrastructure which you can copy 3, 5, 6 times, and in case one of that drops, the availability set or the availability zone will take care that the application is still available. Finally, I would like to mention the regional pairs. Here in Azure, you always have 2 regions within Azure which are paired. That means that you have additional functionality between these 2 regions. For example, the storage synchronization is one of that, or you have the Azure Site Recover, where I will dive deeper in one of my next slides. I mentioned in the slide before also the vendor support, and it is quite important to also have a look which HANA instances are really supported or certified with Azure, and unfortunately not all instances are certified at that point in time. So that means there might be a server which might fit from the size and which might fit from the performance, but unfortunately it's not certified for SAP, and therefore you can't run it productively in the cloud. That doesn't really fit for the non-production systems, but nevertheless, at least the QAS system should be built similar to the production system to be able to test really all configuration before you migrate it to the production system. Now I would like to dive a little bit more into the regional pairs. Each block here in green is displaying one region. Let's assume on the left side, for example, Western Europe, on the right side, Northern Europe, which means Amsterdam on the left side and Dublin on the right side. One region means there are several data centers built as a combined region. So for example, in Amsterdam, you do have 7 independent data centers which have a distance of roughly up to 20 kilometers. So for standard scenarios, you already have a quite well coverage for a disaster, but this is not a disaster as defined within Azure. Therefore, Azure offers us the possibility comparable to the functionality, I would like to say, in VMware with SRM. They do have an ASR, which means Azure Site Recovery, which takes care that data which are written in the primary region are synchronized over to the other side, and in the hopefully unlikely case that a complete region, you remember that at least 7 data centers are dropped, then it will automatically take over within the secondary region. Nevertheless, you should always consider in here backup, and here you have the option of the blob storage, and for blob storage you have also several options in here. You have the local redundant storage, which is a 3 times copy within one data center. You will have the zone redundant storage, which is a 3 times copy within one region. Then you have the global redundant storage, which is a 6 times copy, 3 times in the primary region and 3 times in the secondary region. And what I always would recommend is the read access GRS storage for backup, because that is the same like the GRS as a global redundant storage itself, but gives you the chance to access directly the backup within the secondary region. which is otherwise only accessible via ticket and interaction by Microsoft. So with the read access GRS, you will also always be able to access directly in case of DR, your backup in the secondary region. This configuration will work for a lot of things, but I wouldn't recommend it for databases with a lot of change rates. You might can use that for a BobJ server which only stores configuration data in the database. Then it might work, but in general I would use the ASR only for the application server central instances and things similar to that. If you then need to consider as well databases, we would like to have the next level of configuration. Here, as you can see, we would need to split the central instance and database and application servers from the database, which can be HANA, which can be Sybase ASE or SQL Server, whatever you like. And then you need to take care that the databases stay in sync via using database native tools. For HANA, we would definitely use HANA replication for that. For the application in front of that, that can be an application server combined with a central instance, or a central instance and several application server up front. These you can guard by using ASR. The same works for Web Dispatcher. Again, the backup concept is like mentioned below. For many applications, for many customers, that is already a fitting configuration. With that configuration, keep in mind for each application server and for each virtual server, you already get a 99.9% availability. Together with the possibility to have everything synced into a secondary region, you would easily you would be able to easily offer an application availability around 99.7, 99.8. If you need a higher availability for your customers, because 2 hours maximum downtime will not fit your requirements, because lorries will not leave your company if the system is not available, or you have a high impact on customer requests, then you are able to scale that up. And here I prepared 2 possible scenarios. The first one is a single HA configuration where you secure your web dispatcher by having the availability sets, availability zones, having several web dispatchers in there, which are routed through a load balancer. Behind that, you will find a clustering based on SUSE cluster for the central instance. The application servers again can be scaled out using a similar functionality like we use for the web dispatcher. And on the database layer, you would work with a HANA scale out functionality. To build that in also into a DR scenario, you would then be able to expand that using again ASR for the web dispatcher layer, using ASR for the passive node of the cluster, and then you would use the HANA replication, including the master-slave functionality within the primary region. Okay, before starting your journey into the cloud, I would like to remind you, please check upfront which cloud fit best your needs. Each cloud has its benefits. You will need to consider what fits best. Where have you maybe already started your journey to the cloud? Is the functionality within the cloud sufficient for you? And which SLA do I have? Based on the SLA, you need to consider which of the scenarios I showed up front will fit best for you. And as mentioned by Stephen before, always take care of your backup and the monitoring service. Please consider upfront, this is not an out of the box service in the cloud. You might need to bring in your own tools. You might need to connect that to your already existing environment. That might be not a simple task. And it always sounds quite logical, but how will I access my environment? You need to be able to access your environment even in the unlikely case that your standard connection will not be available. Then you need to have a backdoor to bring your environment back to life. And of course, always consider SUSE HA scenarios combined with HANA clustering when necessary. So therefore, I'm now through with my slides, and I would like to thank you for your attendance, and I'm looking forward to meet you again on one of the SUSE conferences. Thanks also to Stephen, and yeah, looking forward to meet you again.